All right, we're going to do a little bit of graphing today. Graphing of linear inequalities. This is good stuff. Here's where you're going to start in your thought process. Think about the line type. Here's what that means. If I have a less than, that's going to be a dashed line. Actually, these two, a less than or greater, these are dashed lines. And that's because the line itself is not part of the solution. That's why we use a dashed line. That a point that is actually on that line is not included in the solution for that. But when we come over to things like less than or equal to and greater than or equal to, these guys will have a solid line. And that means that a point that is on the line is actually a solution to the inequality. And a couple videos ago, I know I dealt with, we were plugging points in to an inequality to see which ones would work. The ones that you plugged in that would actually work would be on the solid line. I'm getting a little bit lost here. Yeah, solid. So a point right here, if I have a point on the line, on a solid line, it's actually a solution. A point that's on a dashed line is not a solution. So think about the line type. That's your first thing. Then you're going to ignore the inequality. You're going to graph the line, pretending that it's an equation. So we're ignoring the inequality and we're just graphing a line, which we've done lots of times. But make sure you graph it using the correct line type. Then you're going to test a point and shade the true region. Okay, so think about the line type, graph the line, pick a test point, shade the true region. And the test point that I like to use, pick a test point, 0, 0 is frequently just a great test point to use. 0, 0, 1, 1. Okay. See if you like this. See if this is good stuff. So here's our equation. I need to graph, first off, what's my line type? My line type is, what is that? That's a solid, okay. My intercept is at -2. And I'm going up 6. Right, here's my slope. I'm going to go up 6 over 1. 1, 2, 3, 4, 5, 6 over 1. So here's my line. It's solid. So when I draw it, I'm going to draw in a solid line. Perfect. So I knew it was going to be solid because of the inequality, the greater than or equal. Then I graph it, just ignoring the inequality, just graph it like a normal slope-intercept line. Now I'm going to pick a test point and see if it's true or false. I'm going to choose 0, 0. I'm going to plug 0, 0 into this equation. That's going to give me some answer that's either going to be true or false. I'm going to then shade the true region of this graph. See if this makes sense when I do it. Here we go. 0 is greater than or equal to 0 minus 2. I plugged 0, 0 into this equation. 0 is greater than or equal to -2. Is this true or false? Is 0 greater than or equal to negative 2? This is true. So the point 0, 0 is a true point. Well, what does that mean? Does that mean that the area above the line is true, or is the area below the line is true? Well, this true point is in the area above, which means the area above is the true region. So now I'm going to shade this in. There we go. What does this mean? It means that any point over here, any point over in this kind of shaded region, any point over here will make this inequality true. What about this region? It means any point over here in this region will make the inequality false. Well, what about points that are on the actual line? Points on the actual line will be true because it's a solid line. The points on the solid line are true points. If I take one of these points from this line, plug it in here, it will be a true point. Let's do another one. Okay. First off, line type, solid or dashed? Dashed. Keep that in your head. Okay, now it's time to graph this thing. Now, unfortunately, this guy is in the wrong form, so let's put it into slope-intercept form, try to make it a little bit easier to work with. I'm going to have 7y is less than negative 5x plus 7. So I have y is less than negative 5/7 x plus 1. Now it's ready to graph. So let's graph it. My intercept is at 1. My slope is down 5 over 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And I'm totally off the graph, or off the video, right? Down 5, 1, 2, 3, 4, 5 over 7. 1, 2, 3, 4, 5, 6, 7. There's my line. Is it solid or dashed? It's a dashed line. Now we're going to pick a test point and figure out where we need to shade. 0, 0 is a great test point. Let's see what 0, 0 is doing for us. 0 is less than 0 plus 1. 0 is less than 1. 0 is less than 1. Is that true or false? That is true. So this point right here is a true point. So the true region is below the line. There we go. What does this mean? It means that any point down here in the true region, in the shaded region, will make this inequality true. It means any point up here, point, any point up here, if you plug it into the inequality, will make the inequality false. The line itself, any point on the line itself is false. And that's because it's a dashed line. The dashed line tells us it's false. Okay, that's it for that one. That was a little bit long. That was a 10-minute video. Okay, that's it. Bye-bye.